Welcome back, class. I'm Mr. Teacher with the SAT Math video guide, and I've been suddenly intrigued by drawing squiggles on my blackboard while I wait for my videos to process, and it's really fun. You guys should try it out yourself. I'm actually gonna research squiggly lines, even though that doesn't sound like anything to research on, because they have to do with something with geometry, most probably, because they're just one single line shaped into many different shapes. But anyways, instead of rambling on about that, we're here for SAT Math, and today we're starting on test number 4. So finally we are getting putting on steam on the video train, and I'm managing to make videos a bit more quicker now. So it begins from section 3, and we're gonna get started on number 1. So let us move away from that beautiful squiggly. And so, if 3b plus 1 is less than 10, which of the following cannot be the value of b? So they gave us the equation is 3b plus 1 must be less than 10. So which of the following cannot be the value of b? Let's solve this inequality. So let's get rid of the 1 on the left-hand side by subtracting 1 on both sides. 3b has to be less than 9. Then we divide by 3 on both sides. We get b has to be less than 3. And the only option here that's greater than or equal to 3 is, well, 3. It's choice E. And that's the number that cannot be the value of b. Since b can only be less than 3, b is not less than or equal to. And plus, if you plug 3 into the equation, it's not going to work. It's going to say 10 is less than 10. That doesn't make sense. So, pretty straightforward first problem. We're going to move on to number 2 right on the same scroll. So, it asks, if 2 to the power of 4x equals to 16, then what does x equal? Well, let's write this equation out over here. It says 2 to the power of 4x is equal to 16. Now, when you see an equation like this where one side has powers and the other side doesn't, think of the side that doesn't have any powers as a base number of the number that has powers on the other side, and try to add exponents to it to see if you can get the same value. So what I mean by that is 2 to the power of 4x. If it's equal to 16, well, you can write 16 in terms of base 2. It's 2 to the power of 4. So now we know that the exponents are equal since the bases are equal as well. So we can write out that 4x is equal to 4, and therefore x is equal to 1. And that's choice A. Choice A is the correct answer. Number 3 looks like a small one, and I'm just going to do it here. I don't need to squeeze it in. It'll fit pretty easily. How much greater than r minus 2 is r plus 5? Well, let's write out in this equation. R minus 2 is less than r plus 5. Now, this is just a little bit of a longer way to try and understand what exactly happens during the math. So you can add 2 to both sides now, and be r is less than r plus 7. Or you could do it the other way around. You could also subtract the 5, and you would get r minus 7 is less than r. In either case, this 7 is the difference, because you've already calculated the absolute value. Basically, this is what you exactly did. You calculated the absolute value between both numbers, and you got it. And another thing you can do is just do a straight down absolute value calculation. 5 minus 2, which would be 5 plus 2, 7, or negative 2 minus 5, which would also yield 7 because it's an absolute value. So either way, choice E is our answer to go with. So now we'll go to number 4, which has a diagram. I will draw a very bad representation of the diagram. fear not, I'll explain it perfectly well, but it's just that I'm not the best drawer. How do you say that? Well, you say artist, but couldn't you also say drawer? It always makes me wonder, these small things. But that's sort of how it looks like, with a length of 4, a width of 3, and a height of 2. So, if the rectangular box with no lid shown above is cut along the vertical edges and flattened, which of the following figures best represents the result? Okay. So it's basically saying, if you were to fold this from a flat piece of paper, before folding it, how would you cut the piece of paper and how would it look like? So we know that the height is 2. Let's just keep it like that for now. And when you make a picture like this flat, the length and the width are gonna go the same direction. So you need to be careful. However, it'll either be that the length is the top and bottom value, and the width is the left and right value, or vice versa. It can also be the other way around, but it's never going to be the length is the top and the right value, and I'm showing you what I mean by that right now. So let's draw out the length of the box, which is this. So this is 2, and this is 4, and this is 2. I'm now drawing the sort of orangish highlighted part of the cube. So then it goes another 2 this direction, right? Because you're going to be connecting these. So basically, this squiggled on line is really 2 faces of the entire cube, and if you were to do this technically, they would just be 2 separate pieces glued together to make it look like one piece. So there's also another piece, which is 2. And then you need to now go with the width. The width is 3. And then you go on a height of 2. Same thing again. And you go all the way. So it'll look something like this. Not as lopsided, but it would look like this. And you can cut the dashed lines out like this. Well, not cut them out, but where you would fold the box. And the one that looked like that is choice E. And that is the correct answer. If you have any problem with the problem still, you can always let me know. I would be glad to answer them. So we're just going to move on to number 5 now, which is just a square, basically. Okay. There we go. Okay, so this is point A, this is point B, this is point C, and this is point D. So, in the figure above, a path from point A to point D is determined by moving upward or to the right along the grid line. So, no moving back, no moving left or down. How many different paths can be drawn from A to D that do not include either B or C? So, we need to pick paths that won't touch the point B or the point C in any possible combination. So, what we need to do is we need to visualize that the lines that are connected with points B or point C are not really there. You could just do this by scribbling a lot of nonsense on the lines. So it would look sort of like this. The lines where I'm scribbling blue on are lines that you cannot take as paths. Because when you finish the path, since you can only move either right or left, since you can only move right or upwards, these are the paths you can't go through, because if you go through them, they will include the point C. So, number 5, we need to find points that don't include C or D in any possible way. Now, one thing you might be wondering if you don't look at the problem correctly, well, Mr. Teacher, how about the lines that are on the right of B and the right of C? I mean, they're going away from the points. Well, to get to that point, you need to go to B, so that's one thing. So, let's use a nice yellow for the outer pathways of A to D. So, there's this pathway, which is 3 up and 3 to the right. There's also 3 to the right and 3 up. And now we have those 2 points. Now let's use a purple-ish color to get the other points. There's also 2 up, 1 right, 1 up, 2 right. And there's also 2 right, 1 up, 1 right, 2 up. So there are 4 possible paths you can follow to go from point A to point D without going to point B or point C. So that is choice B, which is the correct answer. And I believe I can do one more before I need to run out of time. Well, I don't need to run out of time, but I would run out of time. So, okay. Number 6 is 3, if 3/7 of n is equal to 42, what is 5/7 of n? So, this is just solving the equation and then solving the equation again, at least the new equation. So, the first equation is 3/7 of n is equal to 42. And be careful, this isn't 3/7 of 42. This is 3/7 of n, which we don't know yet. So n would be equal to 42 divided by 3 over 7 or multiplied by 7 over 3. 42 times 7 is equal to 280 plus 14, 294, which will be divided by 3, and we would get 98. There we go. That was easier than I expected to calculate. So n is equal to 98. 5/7 of n. So you would have to multiply 5/7 times 98. Instead of doing that, because you're just going to get another big number again and divide it by a small number, you could just divide 98 at this point by 7, and in this case you would get 14. So you know that 1/7 of n is equal to 14. Now, if 1/7 of n is equal to 14, you just need to multiply 14 times 5 to get 5/7 of n. It's sort of just like addition. 5/7 of n is 1/7 of n plus 1/7 of n, so on and so forth. So 14 times 5 is 70, and that is choice A. So I'm going to stop right there. I hope this helped you with your SAT preparation. Expect a lot more videos from me very soon. And I will see you in the next video.